Hello everyone, I'm back with another video today about halohydrin reaction mechanism. So I want to make a really quick note. So in the last video that I talked about the halogenation, I don't know why I had written anti-Markovnikov on there. Just know that halogenation reaction is anti-addition. The reason I'm making this emphasis in this video is because this is also going to be an anti-addition reaction and they follow very similarly. And so as you saw in the halogenation reaction, you form your bromonium and then you're going to attack with your bromine, and the bromine is going to attack again the most substituted carbon. You're going to have a very similar reaction here. But as the name suggests, it's halohydrin. What is halohydrin? Halo for halogen, hydrogen for water. And the reason that I'm making it very clear about what the name is because this is going to save you on the exam. When you're blanking on an exam, it's happened to all of us, and you're like, wait, what was supposed to happen there? It's going to jog your memory about what is supposed to happen in that reaction. Halohydrin, oh, so first I'm going to have a halogen, and it's going to attack the halogen, and then hydrogen means water, so water is going to come into the reaction. And so I'm telling you guys, it jogs your memory, it works. Okay, so let's get into the actual reaction mechanism now that I gave you some hints. So the alkene that I have drawn below, I show you that I have two hydrogens on one side and I have two methyl groups on the other side. And so you're going to see why I'm telling you this in a little bit, and I'll make the connection at the end. Well, first you have your double bond. So the double bond is a pair of electrons and it's going to go and attack that bromine. Well, then what's going to happen is those other electrons are going to go to the other bromine. Okay, so far so good. You form your bromonium, which is what will happen in the other reaction, in the halogenation reaction. But now notice what happens. Water is going to attack. Hydrogen. Okay, got it. Again, water is going to attack the most subbed carbon. Then those electrons again are going to go to the bromine. Oh, quickly. Notice that you formed bromonium, and bromonium is positive, and I'm making emphasis because some of you guys on your exam, you don't write the positive. It matters. Why? The formal charge. If you don't know how to calculate formal charge, you can go check out my video on that, but the formal charge is going to be positive 1, which is why you have your positive charge. Okay, so the water attacks, the electrons go to the bromine, and then what happens? Water is going to have, it attaches, but notice those electrons attached to that carbon, you are going to have a positive charge. 6 minus 5, positive 1. So if you don't know how to go to formal charge, again, go check out that video. But it is important to write that you have a positive charge for the oxygen. Okay, now bromine, the one from the first step, is grabbed all those electrons. It's going to have a negative formal charge. Those electrons are going to go and attack the hydrogen, not the oxygen, the hydrogen. And then those electrons between the oxygen and the hydrogen are going to go over to the oxygen. And then what's going to happen is you're going to have bromine and OH in anti-periplanar position. Okay? So one huge emphasis I want to make in this particular video is that notice that in this carbon, you have two hydrogens. It's not chiral. In this carbon, you have two methyls. It's not chiral. So the molecule at the end is not chiral. What I'm showing is that it is anti-addition and that is the position is anti-periplanar. But do not confuse things. This molecule is not a chiral molecule. You do not have chirality, which is why you don't have enantiomers. And in some halohydrin reactions, you will have a pair of enantiomers formed. In this one, I don't, because again, the carbons that I have, they're not chiral carbons. And so I'll make another video on an example of a halohydrin going with a carbon that has chirality and that forms enantiomers. But notice that for this one, again, I don't have chirality, so that's why I'm not forming any enantiomers. But this position, the way that I have it drawn is correct, and you will see it drawn that way because again, it's referring to the bromine and the OH being antiperiplanar. Think of it like they're 180 degrees apart. Again, if you enjoyed this video, please follow, like, share. I want to reach and help as many students as possible in organic chemistry. I personally aced both of them, OChem 1 and 2, and I just want to help you guys also succeed. So again, please like, share, follow. I'll leave any comment if you guys have any mechanisms you want me to go over, and happy studying.